Good morning. Today we are going to see how to find the rank correlation coefficient. Okay, the form rank correlation coefficient. Here we are going to see both repeated and non-repeated ranks. The formula for rank correlation coefficient for non-repeated ranks. Non-repeated rank. The rank correlation coefficient will be denoted by rho of x comma y is equal to 1 minus 6 sigma di square divided by n into n square minus 1. Here di denotes the difference between the rank. Here sigma di is the sum of the difference between the rank x, the rank x, the rank of the variable x, variable x and y. Here the subtraction is only for 6 sigma di square divided by n into n square minus 1. Here n denote the number of data. Next, for the repeated rank, for repeated rank, so we have 1, say the row of x5 is equal to 1 minus 6 sigma di square minus correction factors will be there. Yeah. So 1 minus sigma di square plus correction factor divided by n into n square minus 1. So here the correction factors will be m1 into m1 square minus 1 divided by 12 plus m2 m2 square minus 1 by 12 plus so on. Here m1 m2 will denote the m1 and m2 denotes the number of times a particular rank was repeated. A particular rank is repeated. Now we'll do a problems both repeated as well as non-repeated ranks. Okay. So now first we'll see a problem for non-repeated ranks. Okay. Take them. The first problem, suppose, okay, problem on non-repeated rank. Uh, The question is, suppose we have rank of 5 students in 3 subjects. They are computer science, comma, physics and chemistry, uh, physics and statistics. And we want to test which 2 subjects have the same trend. Okay, let me see to do the problems. So ranks in computer, rank in computer science, rank in physics, rank in statistics. Okay, the ranks are first for computer science 2, 4, 5, 1, 3. Next, they are in physics 5, 1, 2, 3, 4. Next, for chemistry, for statistics 2, 3, 5, 4, 1. So same trend means whose rank correlation coefficient is positive. Okay. So here we want to find which 2 subjects is same trend. That is, we need to find the rank correlation coefficient. You take the computer science as X and physics as Y and statistics as Z. So now we want to find the rank correlation coefficient between X and Y, rank correlation coefficient between X and Z, and rank correlation coefficient between Y and Z. So we have to find the three rank correlation coefficient pairs in that which value is near to plus 1, near to plus 1, that two subjects that two subjects will have same trend, will have same trend. Okay. Now we'll write in the column wise. So here X will denote the rank in computer science, and Y will denote the rank in physics, and Z will denote the rank in statistics. So we will write in the column wise. So for computer science, you have 2, 4, 5, 1, and 3. Next, for rank in physics, 5, 1, 2, 3, and 4. Next, rank in chemistry, sorry, statistics, 2, 3, 5, 4, and 1. So now we will find the difference between the ranks. So you take your D1, that is x minus y. Rank between difference between x minus y. So 2 minus 5 is minus 3, 4 minus 1 is 3, and then 5 minus 2 is 3, and 1 minus 3 is minus 2. 3 minus 4 is minus 1. Next, your D2, difference between the rank of D2, you can take it as x and z, x minus z. So R1 minus R2. So x minus z. So you will get the value as 2 minus 2 0, 4 minus 3 is 1, and then 5 minus 5 is 0, and then 1 minus 4 is minus 3, and then 3 minus 1 is 2. Next, D3 will denote the difference between the rank y and z. So we can make it as y minus z. So you will get 5 minus 2 is 3, 1 minus 3 minus 2, 2 minus 5 is minus 3, 3 minus 4 is minus 1, 4 minus 1 is 3. Next, d1 square, we need the value of d1 square, d2 square, and then d3 squares. So square it. So d1 square is 9, 9, again 9, and then 4, 1. Next, d2 square will be 0, 1, 0, 9, 4, and d3 square is 9, 4, 9, 1, 9. And we need this sum. So 27, 9 3s are 27, 28, 32. Next, this one will be 9 plus 1, 10, 14, and this will be 9 plus 9, 18, plus 4, 22, 23. So these are the summation of the I squares. So the rank correlation coefficient is summation. We need 1 minus 6 sigma di square. So I got these values. So now we will find rank correlation coefficient first. Rho of x comma y is equal to 1 minus 6 sigma d1 square divided by n into n square minus 1. Here n is the number of data, so 1 minus 6 into 32 divided by 5 into 25 minus 1. Similarly, so we get this value as minus 0.6. Next, rank, here the D2 is between D2, so x minus y and x and z. So rho of x z, so which is equal to 1 minus 6 sigma d2 square divided by n into n square minus 1, which is equal to 1 minus 6 into 14 divided by 5 into 25 minus 1, so which is equal to 0.0 3. This is positive. Next, row of y z is equal to 1 minus 6 sigma d3 square divided by n into n square minus 1 is equal to 1 minus 6 into 23 divided by 5 into 25 minus 1, so which is equal to, say, minus, I'm getting, check it, it is again 32. Yeah, oh, it's not 23, it is 32. Sorry, the counting mistake. But this is 32 degree. So we'll get again 32 here. So which is equal to minus 0.6. Kindly correct it. So here row of x is z, so which is equal to plus 0.3, which is positive. Therefore, x is computer science and z statistics will have same trend. Will have same trend. So once again, I explain the problem. Listen. So here three subjects, five students, and their rank distributions were given. So the five students got the rank in computer science as 2, 4, 5, 1, 3. The rank in their physics corresponding students rank in physics will be 5, 1, 2, 3, 4. Similarly, the same student ranks in statistics will be 2, 3, 5, 4, 1. So rank for computer science I am taking as x, rank for physics I am taking as y, and rank for statistics I am taking as z. So now we will find the rank between AXY, XZ and YZ. So whose rank is very near to positive, that is plus 1, we can take the two subjects I will have the same trend. So X rank will be 2, 4, 5, 1, 3, and the rank for Y is 5, 1, 2, 3, 4, and the rank for Z will be 2, 3, 5, 4, 1. So now we will find the difference between the ranks. So D1 will denote the rank difference between the rank X and Y, and D2 will denote the difference between the rank X and Z, and D3 will denote the rank between the Y and Z. And next we have to compute your d1 square, d2 square and d3 square and sum it up. So the sum of d1 square is 632, the sum of d2 square is 14, and sum of d3 square is 32. Earlier I had taken as 23, it is not correct. So I missed one 9, so it is 32. Now we will compute the rank correlation between x and y. The formula is 1 minus 6 sigma d1 square divided by n into n square minus 1. So if we apply it in this, we will get minus 0.6. Similarly, the rank correlation coefficient for row of x and z between x and z, 1 minus 6 sigma d2 square divided by n into n square minus 1. You will get plus 0.3, and the rank correlation coefficient between y and z is 1 minus 6 sigma d3 square divided by n into n square minus 1. So if we substitute, we will get minus 0.6. Here the rank correlation coefficient x and z is plus 0.3, so which is near to plus 1. So we can take that x computer science and statistics will have same. Okay. So now we'll do one more problems which is on repeated ranks. Okay. The rank correlation coefficient for repeated rank. Rank correlation coefficient for repeated rank. So I'll do a problem. Take note. Calculate the rank correlation coefficient. Rank correlation coefficient for the following data. Okay. So the data will be excess expenditure on advertisement. Write in the column by expenditure in advertisement. Next will be profit. And the data are 10, 15, 14, 25, 14, 14, 20, and 22. And 22. Next, the corresponding profit values are 6, 25, 12, 18, 25, 40, 10, and 7. Now, for the given data, we have to assign the ranks. First, we will assign the rank, and then afterwards, we will find the difference between the ranks. So you take this is your x and this is your y. So rank of x, rank for x. So rank for x. So first you have to take the largest value. So rank for x will be the largest value will be 25. So which is one rank. And the second largest value will be 22. We can assign it as 2. Next the third largest value will be 20, which is 3. Next the fourth largest value will be 15. So assign it as 4. Next the fifth largest value will be 14. There are three 14s are there. So the ranks will be, so 314 means the ranks will be 5, 6 and 7. It is distributed evenly. So we can make it as 5 plus 6 plus 7 divided by 3. We have to take the average of the rank. So it is equal to 6. So it is repeated 3 times. So you take M1 is equal to 3 first. So the ranks are 6. So for 14 you have to evenly distributed as rank as 6. So 6 and then here 6 and then 6. So now the rank 5, 6, 7 is over. The last rank will be 8. So it is given for 10. So that is rank 8. Clear? This is the way we have to distribute the rank. Next, the rank for Y The largest value will be, here it is 40, which is 1. Next, the second largest value will be 25. So there are two 25s will be there. So the rank 2 and 3 will be shared. So rank 2 plus 3 by 2, which is 2.5. Now the M2 value will be, the rank will be repeated 2 times, so 2, and we have to divide the rank as 2.5, and one more 25 is 2.5. Next, that rank 2 and 3 are over. Next, the fourth rank. So after 25, the largest value will be 18. So 4, and next the largest value will be 12, which is 5. Next, the largest value will be after 12. The largest value will be 10, which is 6. Next, the largest value will be 7. We can assign the rank it as 7. And the largest, next value will be 6. We can assign the rank as 8. The ranks will be given by ascending order. Next, DI values. So DI, so difference between their ranks. So 8 minus 8 is 0, and then 4 minus 2.5 will be 1. Next, 6 minus 5 is 1, 1 minus 4 is minus 3, 6 minus 2.5 will be 3.5, 6 minus 1 is 5, 3 minus 6 is minus 3, 2 minus 7 is minus 5. So di square x, so d 0 square is 0, 1.5 square, which is 2.25, 1, 3 minus 3 square is 9, 3.5 square is 12.25, 5 square is 25, and 3 square is 9, and 5 square is 25, which is total is 83.50. Okay, summation of di square. So we got summation of di square, the value is 83.50. Next, we need to compute the correction factor CF, which is equal to M1 into M1 square minus 1 by 12 plus M2 square minus 1 by 12. Here the M1 is 3. So 3 into 9 minus 1 by 12 plus 2 into 4 minus 1 by 12. The answer is, so 3 into 8 by 12 plus 2 into 3 by 12. So 8 3s are 24 plus 2 3s are 6 by 12. So which is equal to 30 by 12. So if you use the 6 table, 6 5s are 30 divided by 6 2s are 12. The answer is 5 by 2 is 2.5. So we got the correction factor as 2.5, and summation di square is equal to 83.50. Check it. The rate, yeah, 83.50. So the formula is correlation coefficient rho of x, rank correlation coefficient is equal to 1 minus 6 sigma di square plus correction factor divided by n into n square minus 1. Here the n value will be 8. Number of data is given as 8. So you will check it if you want. Our total rank will be 8, right? Yeah. So 1, 2, 3, 4, 5, 6, 7, 8. Fine. So now we substitute the values. So 1 minus 6 sigma di square is 83.50 plus correction factor. Okay, and the 6 is common for outside, sorry, and the 6 is common. The 6 is common for outside, so you will get 6 times sigma di square, so which is equal to 83.50 plus correction factor 2.5, 30 by, sorry, 30 by 12 divided by 8 into 8 8 are 64 minus 1. So we'll get 1 minus 6, 83.5, 83 plus 2, 85.5.5, 86. So 86 divided by 8 into 63. So that will be equal to minus 0.024. So here the value 6 will come outside the formula. We'll correct in the main formula also. Yeah. The in the main formula we have to correct it. Okay. So 6 will be outside of that. 6 will be outside. I correct it. So we got the correlation coefficient minus 0.024. Once again, I explain the same problem for the repeated rank. Now we are going to compute the rank correlation coefficient for repeated rank. So we'll take this problem as an example one. Calculate the rank correlation coefficient for the following data. Here, expenditure for the advertisement and profit was given as X and Y. We will write the given value X and Y in the column wise. So X will denote the expenditure in advertisement and Y denote the profits. So first you have to assign the rank for X. So among the X values, see among the X value, the largest value will be 25, we'll assign it as 1. The second largest value will be 22, assigned as 2. And the third largest value will be 20, assigned as 3. And the next largest value will be 14 in X. So we have 3, 14. So the rank will be 5, 6, and 7. Sorry. Okay. Before that, the next largest value will be 50. That will be assigned for 4. After that, the next largest value will be 40. There are 3 14 in the hand. Therefore, the ranks are 5, 6, and 7 will be shared. So we take the average of the rank 5 plus 6 plus 7, which is 3, 6 divided by 3, which is 6. And you take your M1 value, that is the first implication. We can take it as M1 is equal to 3. There are 3 14, so M1 is equal to 3. So 3 ranks are shared. So 6, 5, sorry, 5, 6, 7. So average of them will be 6. So 6 will be assigned for the 3 14, and then 5, 6, 7 is over. The last one, the 8th rank will be assigned for the smallest value will be 10. Next for the rank for the Y. So in Y the largest value, first value will be 40, which is assigned as 1. The second largest value will be 25, which will have two places, 25 and 25. Now the repetition, you take M2 as 2, M2 as 2, and the rank will be 2, and the average will be 2 plus 3 by 2, which is 2.5. So for 25, we'll assign as 2.5 and 2.5. The rank 2 and 3 are over. Next, the rank will be 4. The next largest value will be after 28. After 25, we'll have 18. So for 18, we'll assign the rank as 4. And after that, next largest value for after 18, it will be 12, so assign as 5. And after 12, the next largest value will be 10 as 6. And then the largest value is 7, which is 7. And the last largest value will be 6, which is ranked as 8. Now we have to find the difference between the rank di xi minus yi. Okay. Rank of xi minus rank of yi. difference between di denotes the difference between the ranks. So next, right, so we and submit. Next, we have to compute the formula. The rank correlation coefficient value will be rho of x comma y is equal to 1 minus 6 into sigma di square plus correction factor divided by n into n square minus 1. First, we have to compute the correction factor. The correction factor formula will be m1 into m1 square minus 1 by 12 plus m2 into m2 square minus 1 by 12. So here m1 is equal to 3 and m2 is equal to 2. Substituting this, we get the value correction factor as 2.5 and summation of di square we got it as 83.50 and the number of data here it is given as n is equal to 8. Okay. So you have to substitute everything here. The row of x comma y, that is 1 minus 6 times sigma di square is 83.50 and the correction factor is 2.5 divided by n is 8, so 8 into n square 64 minus 1. If we simplify, we will get minus 0.024, that is negative correlation. So here we got the rank correlation is minus 0.024, which is negative. Thank you.